All right, welcome to The Explainer. Today, we're jumping into something that's, seriously, one of the most fundamental tools you'll ever use as a programmer. I'm talking about arrays. And listen, if you've ever felt like you're drowning in data, just trying to keep track of everything in your code, this one's for you. Okay, so here's the game plan. We'll kick things off by talking about a super common headache, data overload. Then I'll show you the fix, your first array, which is basically a list. After that, we're going to level up to grids, put it all together with a cool example, and wrap up with why this whole thing is such a game changer for your code.
First up, let's talk about the data overload problem. This is one of those classic challenges that literally every single developer bumps into. It's the perfect place for us to start.
So, just imagine this for a second. You're building a game, right? And it's a hit. Now, you've got to keep track of scores for 100 different players. How do you even do that in your code? I mean, are you really going to create 100 separate variables, like player score 1, player score 2, player score 3, all the way up to 100? Ugh, that would be an absolute nightmare to manage. There's just got to be a better way, right?
And of course, there is. So let's dive into the really elegant, really powerful solution to that whole data overload mess. And that solution is the array. So what is it? Think of it like a special container. It's a data structure that lets you pack a whole collection of similar things, like all those scores, under one single name. But here's the real magic. The index. Every single item gets its own little address, its own position number. And that means you can grab exactly what you need instantly.
Okay, so how do we actually make one of these? Well, the very first thing you got to do is tell the computer, hey, I need a container right here to hold my data. This is what we call declaring an array.
And trust me, it's surprisingly simple to create one. What we're looking at here is called pseudocode. It's kind of like a universal blueprint that works for any programming language. And it's just 3 easy steps. First, you declare it. Give it a good, meaningful name, like scores. Second, you tell it the size. In this case, we need 5 slots for 5 scores. And third, you specify the kind of data it's going to hold, so integer for whole numbers. And that's it. You've made an array.
Awesome. So we've got our container. But how do we fill it up? I mean, we're not going to write 5 separate lines of code just to plug in each score, right? That's way too slow. The answer is a loop. It's this super powerful command that lets us repeat an action as many times as we need.
So let's break this down. Step 1, we just tell the computer to loop 5 times. Easy enough. Step 2, inside that loop, we ask the user for a score. And step 3, this is where the magic really happens. We take that input and we place it right into the current slot of our array. See that scores I? That I is our counter. It's our index. It starts at the first spot, then moves to the next and the next, filling up each slot one by one. It's so efficient.
And what about getting the data back out? Well, it works the exact same way, just in reverse. You use another simple loop that just visits each slot from the first to the last and shows you what's inside. It's the same beautiful logic. Organized, clean, and incredibly fast.
Okay, so you've totally mastered the simplest. But what happens when your data is a little more complex? What if it's more like a grid? Well, that's our next level, organizing data in 2D.
The way to think about this is actually really straightforward. A 1D array, the thing we just covered, that's like a single row of items, a list. But a 2D array, that's like a full-on table or a grid. It's got both rows and columns.
And honestly, this is the perfect analogy. Just think of a 2D array exactly like a spreadsheet, right? To find any single cell in a spreadsheet, you need 2 pieces of info, the row number and the column number. It is the exact same principle for finding data in a 2D array.
So if a single list needs 1 loop to fill it, it just makes sense that a grid needs 2 loops. We use this thing called a nested loop. The outer loop takes us down the rows one by one. And for each of those rows, the inner loop zips across, filling in every column for that specific row before we move down to the next one.
All right, theory is great, but let's make this real. It's time to see how this all clicks together in a fun, practical example that really shows off the power of a 2D array.
Okay,
Here is our mission, should you choose to accept it. We're going to build a grid of K-pop idols. The plan? We need a 2x3 table to hold all their names. We'll use our new nested loop skills to fill it up. And of course, we're going to use good habits like clear variable names to keep our code super readable.
So, we go ahead and write our code using those nested loops we just talked about. We run the program, and it'll ask us to type in the names one after another to fill up our grid. So, after all that, what does our final organized data look like?
And there it is. Look at that, a perfectly organized 2x3 grid. This just shows so clearly how a 2D array works. We've got our 2 rows, our 3 columns, exactly like we planned. You can see how Lisa is tucked neatly into row 1, column 1, while V is sitting at row 2, column 1. Every single name has its own specific row, column address. It's all perfectly ordered.
Now that K-pop grid is a pretty neat trick, but what's the big picture here? Why does any of this actually matter? Let's talk about the real power of being organized in your code.
You know, it really just boils down to 3 huge benefits. First, you get to store tons of values under one single name. So goodbye variable 1, variable 2, all the way to variable 100. Second, you suddenly have the power to organize your data logically into things like lists, grids, and tables. And finally, putting it all together, this just makes your code so much more efficient, cleaner, and way easier for you or anyone else to understand.
So look, you now have the fundamental building block for bringing order to all that data chaos in your code. You can manage lists of player scores, grids for games, tables of information. The possibilities are endless. So I have one last question for you. Now that you have this incredible power of organization, what problem are you going to solve first?